Hi everyone. Just finished reading all the discussions from session 2, so I thought I'd pop on this beautiful Sunday morning before hopefully heading outside for a nice walk. And I just wanted to talk to you about some of the stuff I saw in the discussions. For the most part, they were excellent. I hope you have seen that you can learn a lot by going out to some good sources and seeing what's going on. I learn a lot by reading through. I can't keep up with all that literature all the time, so I'm really glad to have 80 people out there helping me sift through it. I did, for the most part, your discussions and responses are excellent. I love the questions that are coming up. I love that you guys are going out and finding other sources to continue the conversation and puzzle this out together. That's awesome. That's exactly what's supposed to be happening. I will say there are a couple, not very many, but just a couple of cases where it's pretty clear somebody comes in, usually at the last minute, but not always, comes in, reads one line from the summary, and then asks the person a really general question about that line. Or comes in and says, wow, this is really cool. How do you think this, affects our search for the life in the universe? Something that general and that big, first of all, doesn't get you any points. And second of all, doesn't advance the discussion. So really, if you're going to post, it's great to be friendly and talk back, but make sure your posts include something substantive, like, wow, I read in another article something that might add to this discussion, or what is the actual process, because we know this about another process and maybe it happens here. Something like that. Most of you are doing exactly that. So if you're unsure what I mean, read through the bulk of the discussions right now and you'll see what I'm talking about. I'm also glad that almost every article I saw came from a really good source. So great for that. A couple of things on the content. For most of you, I think you get what's inside the galaxy and outside the galaxies, and maybe it was a technical thing that you just clicked on the wrong link, but a lot of you are posting things about extrasolar planets in the outside our galaxy sections, and a couple of you talked about other galaxies on our inside our galaxy section. So I just wanted to make sure everybody knows when we're talking about things outside our galaxy, it's almost always other galaxies or structures of voids of galaxies, of groups of galaxies. Things that happen on the cosmological level, on the level of the study of the universe. Those things are outside our galaxy. Inside our galaxy are I'm just going back. Outside our galaxy also is talking about black holes that are in the centers of other galaxies, or black holes are typically outside our galaxy. Having said that, there is probably one supermassive black hole at the core of our galaxy, the Milky Way. And also, when we're looking at things at the scale of stars or groups of stars or extrasolar planets around stars, clusters of stars, and certainly when we're looking at things around planetary levels and inside our solar system, all that is within our galaxy. So within our galaxy, it's not that these things may not exist in other galaxies, we just can't see individual stars or individual groups of stars, and certainly not planets in other galaxies. I hope that makes sense. The cool, well, no, I'm going to save that one for last. The diet of a black hole. There was a question, but a lot of talk about black holes, which are cool, and the question about what is the diet of a black hole. And that's sort of a colloquial term we use. We talk about the black hole eating things. Clearly, it doesn't have a mouth. Maybe that isn't so clear, but it doesn't have a mouth. It's not eating things and digesting things. What it's doing is a black hole is a body that has such gravitational force. There's so much mass, there's so much gravity that everything around it stays orbiting it. We stay on the Earth because we're attracted to the gravitational force of Earth is pulling us down. Everything in this room is being pulled down. That's why it's held down. rockets launch off the Earth only when they can get enough speed to break what's called the escape velocity, that they have enough speed that they can escape the gravitational bound of Earth. And black holes are named black holes because their escape velocity, the velocity something needs that it could escape its gravitational bounds, is so great that it's even faster than the speed of light. The speed of light is the fastest speed we know of. And it's so great that even at that speed, light can't escape, meaning even electromagnetic radiation can't escape, which is why they're called black, because we can't see something from which electromagnetic radiation can't escape. So, how do we see black holes then? How do we observe them? We observe the stuff that's orbiting around their outsides, that isn't falling in as part of the black hole, but it's just swirling around like water around a drain that hasn't gone down the drain. And by looking at the speed of that stuff, we can tell the mass of the black hole, how powerful it is. Anyway, the diet of the black hole is anything around it that's going to eventually fall in. And there's even some studies, and I know there's some back and forth on this, but you can possibly tell that black holes may dim and brighten and dim and brighten based on the amount of stuff falling into it. And so anyway, that's what's meant by the diet of the black hole, all the stuff around it, the stars and the gas and everything that's around it that are falling into it, making it even more massive. Why is dark matter important? That was an interesting conversation. And thank you, Nick. You came in and actually gave a really nice little answer, nice, eloquent answer, which is the dark matter, the amount of mass in our universe is what's going to affect how fast everything's expanding, and if eventually it slows down, and if eventually it crashes in on itself. And that's been a question of debate over the last dozens, hundred years, so almost. Anyway, that's a whole nother conversation, the Big Bang Theory. But the dark matter is stuff we can't see that's contributing to that mass, that will control or will dictate the end of the fate of our universe. So understanding how much dark matter it is and how it's interacting with all the other matter is very important to understanding the nature of our universe. Maybe not on our personal scales right around here, but on the cosmological scales. Okay, the last thing I want to talk about is phosphine on Venus. And I have to say, I've been teaching this course since almost 20 years, 18 years or something. And I used to get these people, the students come in, and by the end of the whole course, they would write a paper about how Venus is the most likely place for us to find Earth. And I would get so upset because the conditions we knew about Venus were absolutely not conducive to life. It's hot and it's full of carbon dioxide, and it's exactly what we don't want our planet to become. And it's a hellish place. So I would get so upset that I taught this whole course and people would still come away with that because Earth's our twin and it's about the same size as Earth and it's nearby and there's lots of other reasons, but not because of the biosignatures or the conditions we know about and what we know about life. Well, I have to throw all that out the window now because the discovery of phosphine, a molecule that's associated as a biosignature of life, and I assume from what I'm reading that is not associated with many other things because people are so excited that this means that there's possible signs of present or recently past life in the clouds around Venus, not on the surface of the Venus where we know it would be tremendously hot and pressure and you wouldn't want to be there, but this is in the clouds. Now, not saying we want to live in the clouds, but certain molecules might. And that's really cool. Huge new discovery that happened the week this course started, I think. So that's what happens in this class. Stay tuned. Really, really exciting things happen. All right. I hope that gives you a nature of the kinds. I hope this past discussion period has given you insight into what the discussions can be, how to strive for your best in the discussions, how to help your classmates learn, and also some questions may still be going unanswered. Please feel free to email me with a question. I can't read and react spontaneously to all 80 students all the time. I have two sections of this. So, but I do want to make sure that you're getting what you want out of it, and certainly that you're not going away with misunderstandings. So if anything's unclear, email me. I'll come in and write a response to you, or in the discussions, or like this on a video. Thanks. Let me know if you have any questions. I'll be posting discussion marks soon. Oh, that's the last thing. If you got fewer points than you expected on your discussion, you probably either didn't do all 7 postings, did them late, or all crammed up against the last deadline, and or a few of your postings didn't count because they were not substantive. All right, I hope that helps you along, and let me know if you need anything. Bye.